In this module, we will address electric cars in a policy perspective. More specifically, the public policy perspective, the perspective of government and public administration. Why does public policy matter, you may wonder? Should a technological innovation like electric vehicles not find its own way into the market? Why are government interventions needed at all, and how should these be shaped? In this section, we will focus on the first question: why should government intervene to stimulate electric mobility? In a democratic society, government intervention must be justified. It is not enough to specify the problem to be solved and the goal to be reached. We must also ascertain the public interests at stake. Public interests are, for example, concerned with public health and safety, safeguarding the rule of law, ensuring equal treatment of all citizens, and protecting the weakest members of society. Government is in place to protect public interests and safeguard public values. Let us start now with the problem to be solved and the goal to be achieved. Poor air and water quality, climate change, energy security, renewable energy usage, sustainable mobility and social welfare are amongst the key issues to be addressed. We see governments around the world embracing electric mobility as a solution or part of the solution to a wide range of problems where the public interest is at stake. Which problems then are electric vehicles supposed to solve? I will briefly review the various policy challenges where electric vehicles are providing solutions. The first one is public health policy. Air quality is a serious challenge in many cities today. We all know the pictures of severe smog in megacities like Beijing and Delhi, but even in cases where air pollution is not visible to the naked eye, it poses a clear and present danger to public health. Road traffic is a major cause of urban air pollution, as the car exhaust fumes of conventional cars, trucks and buses contain many compounds that affect our health, including NOx and particulate emissions. NOx refers to both nitric oxide and nitrogen dioxide, which contribute to the formation of smog and acid rain. NOx reacts with ammonia, moisture and other compounds in the atmosphere to form nitric acid vapor and related particles. Internal combustion engines on diesel and gasoline also emit fine particulate matter in the form of soot. The European Joint Research Centre, the JRC, and the World Health Organization have identified the main categories of particulate matter in urban air in 51 different cities around the world. In these studies, PM2.5 and PM10 are used as indicators for air quality. PM2.5 stands for all particles smaller than 2.5 micrometers, and similarly PM10 for all particles smaller than 10 micrometers. And as you can see in this slide, the sources of particulates in ambient air vary around the world, depending on the type and intensity of industrial activity, depending on the intensity of traffic and the quality of transport fuels used, depending on the fuels used for heating and cooking, but also depending on natural conditions, such as salt particles in the air in coastal regions and dust particles in desert areas. Chronic exposure to particulates in ambient air leads to a number of health risks. All types of very fine particulate matter can penetrate deeply into sensitive lung tissue and damage it, not only causing or worsening respiratory diseases such as emphysema or bronchitis, but also affecting the cardiovascular system and aggravating existing heart disease. As you can see in the next slide, the various sources of particulate matter in the PM10, the 10 micrometer fraction, show a different distribution than in the 2.5 micrometer fraction. But on average, the research of the Joint Research Centre and the World Health Organization shows that traffic is the biggest source of air pollution worldwide in cities, responsible for roughly 1/4 of particulate matter in the air. So now you understand why governments around the world are embracing electric vehicles. Electric vehicles are emission-free, and moreover, they are silent, and hence bring major improvement to the ambient air quality and the livability of the urban environment. The importance of this improvement cannot be underestimated when you realize that already more than 50% of the world's population lives in cities, and that between today and 2050, the population in urban regions will increase with 2.5 billion people. Let us now move to climate change policy as the second policy domain. Conventional vehicles not only emit NOx and particulates. The combustion of hydrocarbons also results in carbon dioxide emissions. Carbon dioxide may not be the most potent greenhouse gas, but the massive volumes of carbon dioxide emissions worldwide make it by far the biggest contributor to the phenomenon of man-made global warming. In December 2015, the United Nations Framework Convention on Climate Change, the UNFCCC, adopted the so-called Paris Climate Agreement, which entails a commitment to keeping the global temperature rise this century well below 2 degrees Celsius above pre-industrial levels, and to pursue efforts to limit the temperature increase even further to not more than 1.5 degrees centigrade. As of November 2017, 195 UNFCCC members have signed the agreement. The threat of global warming is another reason why governments are interested in emission-free electric mobility. So, within the framework of the Paris Climate Agreement, many countries also signed the Paris Declaration on Electromobility and Climate Change and the corresponding call to action. These countries strive to have at least 20% of all vehicles on the road to be electrically powered by 2030, which is not very far away. Now you may object that electric vehicles may cause indirect emissions at the site where electricity is produced, and you're right. You should realize, however, that it is a lot more cost efficient to remove CO2 from the flue gas of a large power plant than to handle the distributed emissions of millions of vehicles on the road. And by the way, even if electricity is made from coal, the well-to-wheel emissions of fully electric vehicles are still lower than those of vehicles using fossil-fueled internal combustion engines. Moreover, as more and more electricity is being generated from renewable energy resources, the carbon footprint of the electric power system itself should gradually be decreasing. Which brings us to the next policy perspective, the energy policy perspective. All societies are powered by energy, and the share of electricity in energy end use is increasing. Besides the environmental quality of the electricity production mix, with the risk of adverse public health and climate change effects, governments are also concerned about the long-term security of energy supply. And these concerns combined explain why governments stimulate the exploitation of renewable energy resources, especially hydro, solar, and wind. Electricity from these sources is emission-free in both generation and end use. But unfortunately, the supply of most renewable energy sources is variable. Hydropower is subject to seasonal fluctuations and may suffer from years of drought. Solar and wind energy do not only vary by season, but also show strong daily fluctuations and even shorter fluctuations. In other words, a power system with a large share of variable renewable sources needs a lot of flexible standby capacity to cover for periods when sun, wind, and hydro cannot deliver. However, standby generation capacity is often gas-powered, which is not only expensive, it also eliminates part of the environmental benefit of the renewable power system. What's the alternative then? The alternative is to solicit demand response from the electricity end users. The concept here is that variations in the supply of electricity from renewable sources are matched by flexibility in electricity demand. This strategy requires substantial demand elasticity from the end users. The average household in Western economies, however, has very limited demand elasticity. And the trend is that the elasticity is decreasing rather than increasing as more and more household functions rely on electricity. And now, this is where electric vehicles come in. A huge flexibility potential on the demand side can in the future be unleashed by controlled charging of their batteries. That is, in response to the fluctuating supply of electricity from renewable sources. This strategy is also known as grid-to-vehicle steering or smart charging. And at the same time, the combined batteries of electric vehicles represent a substantial storage potential, so that the other way around, vehicle-to-grid services are also possible. The batteries can supply power to the grid during times when renewable sources fall short. In this vision of the future, which obviously requires a lot of ICT support, electric vehicles are seen as active components of the power system. This would entail a revolution, both for the power system and the transport system, which are, with ICT infrastructure, merging into one new infrastructure system, which brings us to the transport and mobility system, the domain of transport and mobility policy as the next policy domain. Transport of persons and goods is a key factor of economic value creation in any society. The transport policymaker will want to know if electric vehicles will be able to perform the same duties as conventional vehicles do. Will electric vehicles change mobility patterns, and how? What refueling infrastructure will be required? Just battery recharging for battery electric vehicles, or also hydrogen fueling for fuel cell electric vehicles? Will it be one of the two or both? In modern societies, car use is considered a key element of individual freedom, and any interference with this freedom is politically sensitive. Yet, policymakers are challenged to accommodate future mobility needs in a responsible way that is efficient, clean, affordable, inclusive, etc. But using a car does not necessarily imply owning a car. In Western societies, the young urban generation is more and more inclined to car sharing and to using Uber-type services if they are not walking, biking, or using public transport. And this trend may in the future even be reinforced by autonomous, that is, self-driving electric vehicles. In that case, cities may be able to reduce the space reserved for automotive mobility, including parking space. Anyway, the future of mobility with electric cars holds a lot of promise for the livability of the urban environment. Livability and accessibility, in turn, are important factors for businesses in deciding on a favorable location, which brings us to the next and final policy perspective on electric vehicles, which is the economic policy perspective. Economic growth is probably the most important objective of economic policy in order to create more welfare for society. It is, amongst others, accomplished through stimulating knowledge development, innovation, and entrepreneurship, which can trigger productivity improvements and the establishment of new firms that create new employment opportunities. Industry policy aimed at enhancing the performance of established industry sectors and creating new growth opportunities may be another component of economic policy. In view of the challenges posed by climate change and the transition to a sustainable energy system, the new economic policy mantra is green growth. It is in this perspective that policies to support electric mobility may be designed. Just as an example, in its research and development programs, the European Commission has for years been striving to establish a strong European technology position in battery technology. And recently, in October 2017, the European Commissioner for Energy, Maroš Šefčovič, announced he is making billions of euros available to support the establishment of large-scale battery manufacturing facilities in Europe, with which he aims to create 4 to 5 million new jobs. It's time to wrap up. Electric cars seem to solve a great variety of problems where public interests are clearly at stake, such as public health, climate change mitigation, energy security, mobility, and a prospering economy. The table here gives a summary of the policy domains and the corresponding policy goals which we have just discussed, and indicates some of the specific policy targets to be reached. It is, however, difficult to design policy instruments in support of more than one specific policy goal. Another challenge is that government is not a monolithic institution. In the introduction of electric vehicles, not only different policy domains are involved, but also different levels of government, at the national level, at the local, and at supranational levels. And this situation, as we will see, results in a variety of policy instruments being applied. I hope to see you in the next module.